Okay, today we're going to talk about the state of matter. This is for Igcse chemistry. This is the first chapter that every Igcse chemistry student is supposed to know in your course of what study. Okay, let us proceed. Everything in the universe is made up of particles. And what are these particles? They can be atom, can be molecule, and they can be ion. So matter is anything that has mass and occupies space. So we have three kinds of matter, three states of matter. We have solid state, the liquid state, and the gaseous state. You can see if you check everything in this on this chart, or even in our present world today, you see that they all fall in this line. They can either exist as a solid, or as a liquid, or as a gas. Although we have plasma state, but we're not going to talk about plasma state in this video. So our main focus is on the three common state of what matter. So matter can be an element, can be a compound, or also what be a mixture. Matter can also be a solid, a liquid, and a gas. All matter contains particles, and particles are atoms, molecule, and ions. All matter occupies space, and they have mass. So these are what can constitute matter. Okay, let's proceed. Okay, let's talk about the properties of matter. For the solid, they have what fixed volume. For example, you can say solid here. That's a fixed volume. This is the length, and the height, the breadth. So you can easily get the volume. All solid have fixed volume. Liquid has fixed volume too. You can see the volume of a liquid that have fixed volume. All liquid have fixed volume. You can see. Gas, on the other hand, they do not have fixed volume. They expand to fill the container which they contain. Solid have high density. Liquids, they have density which can range from moderate to high. All gases have low density. So for solid, they have a definite shape. All solid have a definite shape. You can see they have a definite shape. You can see they are regularly arranged, have a definite shape. Liquid does not have a specific shape, but they take the shape of of the container which they contain. For example, you can see when you pour it in this one, it takes the shape. In this one, it takes the shape. This one, it takes the shape. This one, it takes the shape. So they don't have a specific shape, a definite shape, but they take the shape of any container which they contain, which they are poured into. So gases does not have a definite shape, but they take the shape of the container which they are containing. For example, you can see this balloon when it's on this shape, and the gas take the shape when it's the shape. So you can see gas and liquid are similarity when it comes to shape. So solid don't flow. Liquid generally flow. That's why when you pour them, you can see flowing gases flow. So they are called fluid. They are called both called fluid, so they can flow, except for solid, which cannot flow because of what are compacted and because of the force that is holding the particles together. So let's talk about the kinetic theory. Kinetic theory is just like it's something that talks about the movement of the particles in the three states of matter. So according to the kinetic theory, all matter is made up of very small particles. Different substances contains different types of particles, such as atoms, molecules, and ions. And these particles are moving at all time. You can see they are moving at all times, this particle. So the higher the temperature, the higher the average kinetic energy. You can see that as you increase the temperature, the particles gain more energy and move. So they are all matter process of particles. The freedom of movement and arrangement of the particle is different for the three states. That is, how the movements is described in the three states are different: solid, We are going to talk about it later. So they do not move, the particles in the three state of matter, they do not move at the same rate. So there is difference in their movement. The pressure of a gas is produced by the atom or molecule of the gas hitting the walls of the container. And so as the gas particle, you can see, hits the wall of the container, they generate pressure. The more they hit the container, the more they generate pressure. So these are the main theory you have to master about what the kinetic theory of matter. How the particles are arranged in the three states of matter. Okay, for the solid, the particles are arranged they are in regular order. I can see they are in regular order, all in lattice. So they are regularly arranged, and they vibrate in their fixed position. You can see they are vibrating their fixed position. Particles are closely packed and are held together by a strong force of attraction. So the higher the force of attraction, the lower the energy. So solid particles, they have low kinetic energy but high force of attraction. That is why they are kept in one position. So they merely vibrate in their fixed position. So for liquid, they are irregular in shape or random. You can see they slide over each other. They are less close and they have weak force of attraction. That's why they're able to slide over each other and move, unlike solid that is regularly arranged. So for the gas, they are irregular or random. You can see similar to that of liquid. They are moving very fast. You can see because they are moving very fast and they are far apart. They have the weakest force of attraction and they possess high kinetic energy. So let's quickly answer these questions. The question says a liquid has a fixed volume but takes up the shape of the container. Okay. A gas takes up the shape of the container. I can see one thing is common to both of them. They both takes up the shape of their container. A gas takes up the shape of the container, but it does not have a fixed volume. Okay, can you pause this video and tell us the answer? Okay, why they take the same they take up the shape of the container because of the particles are randomly arranged, that is, they are irregular. As in the particles move randomly in both of the liquid, so that's why they can move to take the shape of the container like they are in. So why the gas cannot spread? Because of the bonds and the movement. Okay, for the gases, they have very weak force of attraction between the particles, unlike the solid, they have intermolecular force of attraction. And gas molecules can move apart to fill the entire volume, which is opposite in liquid. So you can see the difference. So why they both takes up the shape of the container? Because of the particles are randomly they are randomly arranged in both the liquid and gas. But the difference between when it comes to the gas not having a fixed volume and the liquid having a fixed volume, because the force of attraction and how the particles move in them. So they now say compare the movement and arrangement of the particles in solid nitrogen to those in nitrogen gas. So what you have to focus on is the movement in solid and gas. You understand? So we have to compare them in terms of all their movements. How does the particle move in solid? They merely vibrate. For gas, they move very fast. In terms of arrangement, you have to explain in terms of distance and in terms of pattern. Okay, you must always tabulate your work and compare them. So in terms of distance, these particles in solid are closely packed, while that of the gas are very far apart. So in terms of movement, the solid particles vibrate in their fixed position, while that of the gas, they move very fast. In terms of pattern, the solid are regularly arranged, they are regular in shape, in nature, in shape, while the gas are irregular. So when you answer this kind of question, you have to compare both of them, make a tabular form and compare them in order to earn your mark. And always compare the states of matter in terms of what distance, movement, and what pattern. And these are the what you are required in your exam to give in terms of distance, movement, and what pattern. So these are the changes that the three states of matter can undergo. The change from solid to gas is called sublimation, and the opposite from gas to solid is called deposition. So changing from solid to liquid is called melting. Melting is change from solid to liquid. The temperature at which melting occurs is called melting point. Freeze is the change from liquid to what? To solid. The temperature it occurs is called what? Freezing point. And don't forget, the temperature is the same for both the freezing and this. For example, water melts at what? 0 degree and freezes at what? 0 degree. So changing from what liquid to gas is called boiling or evaporation, while the opposite is called condensing or condensation. So you have to master this. So boiling is the change from liquid to what? Gas, likewise evaporation. But I'll still tell you what the difference between these two guys. So let us talk into the difference between the two. Boiling occurs when a liquid is heated so strongly that the particles are moving fast enough to overcome all the forces of attraction between them. This causes them to expand and then turn to a gas. On the other hand, evaporation occurs when very fast particles at the surface of the liquid gain enough kinetic energy to overcome attractive forces between them and then break away from gas. For example, the difference that when you check some water, maybe when it rains, you see water on the floor. Particles on the surface of the water, they have high kinetic energy. After they have gained more energy, they tend to break from the attraction holding them with other liquid, the bulk liquid, and what escape. So unlike boiling occurs at a boiling point. That is, water must boil at 100 degrees, but evaporation can occur at any temperature. It can be at 5 degrees Celsius, 1 degree, no matter the temperature. So it occur at any temperature. But boiling can only occur at what a given temperature. Bubbles is see form in boiling. Can see boiling bubbles are forming. No bubbles in evaporation. Can see evaporation, no bubbles. You can see bubble coming. Can see bubbles here forming in boiling. It's a fast process. Can see it's moving very fast. But evaporation is a slow process. So boiling is when you heat your liquid and particles gain energy, move very fast. As they move very fast, overcome the attractive force and what? Expand, spread out, like turn into what? Gas. But evaporation, when particles at the surface of the liquid have enough kinetic energy to overcome the attractive force, and so holding them with the bulk liquid and what they tend to what? To escape. You can see these are the two differences. These are the differences between boiling and evaporation. So what then is what happens during melting point and boiling point? During melting and boiling, when substance is heated, particles gain enough kinetic energy to overcome the attractive force between them, move fast and then expand. So for substance to melt, heat or energy must be gained. For them to boil, energy must be gained. So as they gain energy, they overcome attractive forces and what? Move faster and what? Expand in the process. What happens during condensation? During condensation, that is when particles are condensing, they lose their energy. As they lose their energy, they tend to move slowly. As they move slowly, they come near together. Before you know it, the attractive force become what? Appreciable, and they become what? More significant. You understand? So when the particles is cool, particles loses their kinetic energy, move slowly, and then come near to each other. At that point, the force of attraction become what? More appreciable. So during boiling and melting, heat is being gained. The opposite, condensing and freezing, heat is being what? Lost in the process. I hope you understand this. Please subscribe to my YouTube channel. Please, I'm begging. Okay, let's continue. Okay, let me explain the heating and cooling curve. In the heating curve, it just shows how energy changes or energy travels. You can see here, energy is going at this point. This energy is traveling at this point. As energy travel changes in matter, instead of matter takes place. So in this column, we have the solid. When it reaches this point, changes begins, and at this point the temperature remains constant. So you can see the temperature is increasing at this point. When it reaches, it remains constant. So at this point there's a change of state. Solid is changing from what solid what to liquid. So when it reaches place, the change is complete. So it will stop and turn to what to liquid. So temperature begin to rise again. When it reaches place, there will be a change in state. And when the change reaches this place, it stopped. It stops. You understand? So then turn to gas. So equilibrium is happening here. That is what I mean by equilibrium. That is, as here is as solid turn to melting here. Likewise, I also turn freeze towards solid. So this is what the freezing point on the cooling curve is talking about. So change of state takes place. Temperature remain constant here. Temperature will remain constant here. Do you get it? Don't mind my drawing, it's not straight. So you can see when you get to this place, temperature remain constant until the chain finishes before what temperature will rise again. So for the cooling curve, you can see it's returning back from gas to liquid. Here, change of state begins and ends here. Begins here and what ends here. At that time, temperature is constant here. Temperature what is constant here. So it's an equilibrium process. Done. So it's very good that you master this. Let us solve a problem to help you what consolidate your understanding of this heating and cooling curve. So let us solve this. According to the question, it says compound X is a colorless liquid at room temperature. A sample of pure X was slowly heated from minus 5 degrees Celsius, which is below its melting point, to 90 degrees Celsius, which is above its boiling point. Which is above the boiling point. As its temperature is measured every minute, and the results are represented on this graph. This is the graph. So complete the equation for the equilibrium present in BC. This is BC. So the equation, I told you that equilibrium means as it's changing to this side. Likewise, I can also return back just like the heating and cooling curve. So you can see BC. This is the solid region, and solid is changing to liquid region. So we already have what solid here. So what will be our answer? Will not be what the main thing we want to get is the state is changing. So these two arrow here tells that as it's changing to liquid, likewise it also return back to solid. It's a process that occurs at the same rate. So what is the significance of the temperature of this? That is, what does this guy mean? What does it mean? It means the melting point, also the freezing point. You get it? So they say, what is the physical state of the compound X in the region EF? EF is a gas. You can say it's a vapor, or you can say it's a gaseous state. So they say, what will be the difference in the region BC if an impure sample of substance X had been used? So what happened? What happened that impurities lowers the melting point of any substance, while impurities increases the boiling point of any substance. You can see they said which is below its melting point. You understand? They made a statement. So impurities lowers the melting point and also increases the boiling point. Say to 90 degrees, which is above its boiling point. So it will reduce the length of this or make it become slopy. So the line is slower. Now this is where the melting starts from and ends here. But because of impurities, you can shorten it or make it become the line is lower or line slopes. Do you understand? So it's very, very simple and easy to apply. So also here, a cooling curve is the opposite of heating curve. It shows how the temperature of a substance changes with time. As it's cooled from a gas to a solid, here is the cooling curve. What is the state of a substance at room temperature this? So if we just check here at temperature of this, remember at 0 to this is a liquid. So it's a liquid. The answer is that it's a liquid at this state. So the effect of temperature on volume of gas, let us look at it. So when you are, when you increase the temperature of particles, remember they gain enough energy. As they gain enough energy, they tend to want to move continuously. They spread apart as to occupy more volume. So when you increase temperature of a gas, the volume tend to increase. Let's look at this diagram. Say like this, the gas will gain energy and push this piston upward. As they push it upward, they occupy more space. So therefore, increase in temperature leads to increase in volume gas, because the particles they gain energy. The particles, as the energy of the particles constantly increase, the gas particles collide more frequently, greater force, pushing them further apart and also hitting the walls of the container. As a result, this collision, the gas expand to occupy more space. So they gain enough energy to expand and occupy more space. So what is the effect of pressure in gas? Um, uh, when you increase the pressure of gas, the volume decreases. Like you can see this piston, when you push it downward, the gases they occupy lesser space, but the pressure increases and continue to hit the wall of the container very fast. So gas particles generate pressure when they collide with the wall of the container. When the space between them is large, their pressure is reduced. However, at higher pressure, the gas volume is reduced. So when you increase the pressure, you force the gas particles to occupy lesser space. Understand? So increase in pressure of the gas molecule leads to decrease in volume of the gas. Also, what you have to note that when you increase temperature, it leads to high pressure, because the particles gain more energy, collide more frequency, with the wall of the container. As they do so, they generate more pressure. So they said, like they said, a sealed container contains nitrogen gas. The pressure of the gas is due to the molecules of the gas hitting the walls of the container. Use the kinetic theory to explain why the pressure inside the container increases when the temperature is increased. You can see when particles gain energy, they collide more frequency. As they collide more harder with the wall of the container, and this leads to generate more pressure, because if particles have more energy, they move faster, collide collide with more force with the walls of all the container. You already know that pressure is generated when the particles collide with the walls of the container. So when they increase the energy, they collide more frequency, move faster. As they collide more frequently with the wall of the container, they generate more pressure. That's the answer. Very simple. So let's talk about diffusion. So what is diffusion? Diffusion is the spreading of particles, can be in liquid or in gas, from a region of higher concentration to a region of lower concentration. So the spreading of particles from where they are higher to where they are less is what we call diffusion. For example, when you open the perfume in your room, you can spread to go to the parlor where your family are. So, okay, look at this. This is a gas jar that contains bromine. After some hour, you see the particles spreading to fill this container. You understand? So that's called diffusion, moving from region where they are higher to region where they are less. You can see. Okay, let us look at this diagram. This is where they are high in concentration. So the particles move from here to this place. You can see higher, they are more concentrated here. Now that diffuse to occupy this place. That is diffusion, the movement of particles from region of higher concentration to region of lower concentration. And diffusion in liquid is very slow compared to gas. Gas is very faster because of the high energy they possess. Can also happen in liquid. You can see when you drop particular dye or potassium permanganate, you see them diffusing, the particles leaving where they are more to where they are less. So let us quickly answer this question. They say a gas jar of bromine vapor and a gas jar of air are set up as shown in this diagram. The glass slide is removed. Diagram 2 shows the appearance of the gas jar after 1 hour. Which statement explains why the bromine and the air mix together? So bromine is lighter than air is strong. Bromine is lighter than air is strong. Bromine molecule move upward and molecule can move strong. Don't forget that the particles mix with particles of the air. That's why they can spread. So molecules in bromine and air move randomly. So they can particles can only spread when they mix with the particles of the air and they move apart. So that's the answer. So which process has occurred? You can see is diffusion. They have mixed together. So the answer is what? Diffusion. So I said different gases diffuse at different rates. What is meant by diffusion? Diffusion. The movement of particles from region of higher concentration to region of what? Lower concentration. What part of gas molecule affect the speed at which move is the mass. Molecules that have higher mass tend to what? Diffuse slower than those that have lighter mass. So yeah, let's say explain why nitrogen gas diffuse faster than chlorine. You know that nitrogen has a molecular weight of what? Of 28, while that of chlorine is 35, 1.5. No, sorry, 71. So 71. So because at 5.5 multiplied by 2 will give you what? 5.1. So 71. So nitrogen has what? Smaller mass. Nitrogen gas has smaller mass and it can move faster. They say explain why the nitrogen gas diffuses faster at higher temperature. Because of what? It has gained kinetic energy to move faster. Understand? So it's very simple. They say explain why nitrogen gas diffuses faster than chlorine gas. Because of what? The molecular relative molecular mass. Why nitrogen is 28 and chlorine molecule is 71. Don't forget that 5.5 multiplied by 2 give what? 71. So the factors of two factors that affect rate of diffusion are temperature and what? Relative molecular mass. So look at this diagram now. This diagram is soaked. This cotton wool is soaked with ammonia solution, and this is soaked with hydrochloric acid. So if they are allowed to move at the same minute, the molecule will form closer to this spot. The one that has what? The higher mass, because we have what will move faster because of its lighter. And don't forget ammonia. Ammonia is nitrogen plus 3 is 17 gram per mole, while the glucose is 36.5 gram per mole. So you can see that ammonia is lighter than this guy, so it will move very fast until the solid will form close to what? To conc hydrochloric acid, because it's higher in mass. So let's answer the question. We're not going to read all this stuff. Let us focus on here. Say after 10 minutes, a white solid forms in the tube where the gases meet. Write the chemical equation for the reaction of ammonia with hydrochloric acid. So this is the chemical equation. It says name the process by which ammonia and hydrogen chloride gases move in the tube. So it's by diffusion. They say at what point this A, B, C, D does the white solid form? Explain why the white solid forms at that point. It forms at A, and the reason because of what? Ammonia has smaller mass, so it moves faster. That is why it forms at what? A, close to what? Hydrochloric acid, which is higher in mass. So the experiment was repeated at higher temperature. Predict how the result of the experiment would be. Therefore, when you hear temperature, what should come to mind? Gaining energy, moving fast, and all that stuff. The solid form faster because the particles gain enough kinetic energy and diffuse faster. So when they gain energy, they move faster, and thereby what? Allowing the solid to form faster. So that is the answer. Very, very simple and easy. I hope you really enjoyed this video, and please don't forget to subscribe to my YouTube channel. This is an academic channel that will help you to that really want to help you succeed in your academics. So if there's any question you want to ask, feel free to ask me, and I will gladly give you a positive response. Thank you. Bye bye.